Welcome to qnawire.
In this problem, we have to find the radius required for a rotating space station to allow the astronauts on board to have half of their weight on Earth. So, what does that fact actually mean for us mathematically? Well, what causes our weight on Earth is, of course, the force of gravity, mg. And so, if we want that to be half of what it is on Earth, the astronaut's mass itself isn't going to change because that's intrinsic to their bodies, but we can affect g since that is an acceleration. So we know that we want the force on the astronauts, or the acceleration acting on the astronauts, rather, to be 1/2 of g. All right. So on a rotating space station, assuming that there is no other source of gravity, the centripetal force is going to be what causes the astronauts to feel any kind of gravitational force. So that means that mv squared over r is going to be what's equal to 1/2 mg. So that is just ma, our net force. Canceling out the m's, we find that we can rewrite the equation for the radius as 2v squared over g. And since we know v squared and g is just a constant, we can now plug in our numbers that were given and solve the problem. V is 35.8 meters per second, and g is, of course, 9.8 meters per second squared. And when we solve this, we find that r is 262 meters, the solution to this problem.